Welcome back to week 4, and in video 2 we are going to move on and discuss atmospheric stability. This is important because it has to do a lot with how clouds form and also how the atmosphere behaves. It's important for flight, and also it is important to learn about how these different clouds form, and that directly relates to the stability. So if you think about stability, you have two different scenarios here. A stable equilibrium on top. We have a valley with a rock or a ball here in the center. If we were to take this ball and move it up to either side of this valley, we are going to notice that when we let it go, it's going to roll back and end up where it started. Whereas in the second scenario here, where we have a mountain with the ball on top, if we were to push it one way or another, it's going to leave that position and not return to that position. So in a situation where the rock material air moves away from its original position and comes back, that's stable equilibrium. Unstable equilibrium is when you nudge or push that object or air parcel and it does not return. So, for example, stable atmosphere, you have, in this top box here, air is lifted or lowered from its original position, and it resists that upward or downward motion. Actually, it will return back to its original position. Unstable atmosphere, air does not return to its original position, but continues to move away, usually in the vertical motion. One important thing to note, and your book talks about this quite a bit, is the environmental lapse rate. This is important for determining stability and determining whether or not that air parcel will rise or not, or sink back to its original position, because as you travel from the surface out into the atmosphere, the temperature is going to drop at a specific rate. The other thing that's going to happen is the rate of that temperature change as the air changes with altitude, as you climb upward into the atmosphere, changes. So depending on what the conditions inside that air parcel are like, maybe there's more water vapor, maybe it starts out at a higher temperature, it's going to, as it rises, it's going to decrease in temperature at a certain rate, depending on what it starts at. So depending on that rate of temperature decrease and the original starting temperature of that air parcel, as it maybe moves up in the atmosphere, it may cool to a certain point where it will become stable and come back down to its original position. So it might rise, cool, reach the same temperature as the surrounding air, and then it might sink back down again. Or it might continue to rise because it's not cooling fast enough. It's still hotter than the surrounding air, and it's still going to escape and not return to that original position. So that's how environmental lapse rate relates to atmospheric stability. So more details about atmosphere and stability. So if we have a stable atmosphere, that means that rising air, that parcel of air, is colder than the surrounding air. That means it's going to be more dense. So in order for it to rise, it's going to have to be forced to rise. So maybe move over a mountain would force it upwards. That would do it. So that air parcel is going to resist upward motion, and if it moves upward, it's going to return to its original position if it can, or its original elevation if it can. If that parcel is forced to rise, you end up with clouds that will look flat and more spread out horizontally in thin layers. So like the stratus clouds. So altostratus, cirrostratus, nimbostratus are all examples of those flat clouds. And as you have this air aloft, it's going to be stabilizing as it warms or as the air at the surface cools. And you can read your textbook for a list of specific conditions for when you have air that is stable. A very good description in your book. So an unstable atmosphere, this is when you have rising air that's warmer than the surrounding air. And as it rises, its environmental lapse rate is such that, and its starting temperature is such that it's going to be continually warmer than that surrounding air, even though it is cooling. So it's going to want to keep rising because it's less dense. And that air is not going to return back to its original position, and it's going to continue to rise until it reaches the same temperature as the surrounding air around it. So the atmosphere is unstable when the temperature decreases rapidly as you move upwards. So we're going to have this air particle is going to be continually decreasing in temperature, but it's still going to be warmer than that surrounding air. So this is caused by air aloft becoming colder. So if you have that a particle of air, the air surrounding it becomes cooler than that particle of air. That particle of air is now less dense and it's going to rise. Or the surface can become warmer. So if you heat up the surface during the day, we have the air above the land surface starting to warm up, becoming less dense, and then it's going to rise. And again, your book has some great details as well, listing off the certain conditions where this happens. So typically as the day progresses, we start out with a stable atmosphere in the morning, and then it progresses to more unstable. So the surface heats up, and then we have the atmosphere becoming less stable because the air is warming up as well and rising to form clouds, such as those that have vertical development like cumulus clouds. So here we can see kind of the progression of a cumulonimbus cloud. So we have this unstable atmosphere, so that parcel of air is rising and cool. So as it's rising and cooling, it's starting to reach its dew point. So we have water vapor condensing, and we can see the start of a cumulonimbus cloud right here. So as it cools, if that air parcel is still warmer than the surrounding air, it's going to continue to rise and cool and condense, and we're going to eventually develop into the mature stage of a cumulus cloud, a cumulonimbus. It's actually producing precipitation in this case, and we get this huge cloud that can develop over time in a very unstable atmosphere. So the sources of uplift of this air is usually due to solar radiation from the sun heating the ground, and the air above then heating up due to that radiant energy, and then the air becomes less dense and it rises. So that's the main type. So we also have what's called a conditionally unstable atmosphere. This is a little bit tricky. So basically, if you think about it, your book has a great diagram that describes this. So we have a parcel of air that is lifted to a point where it becomes saturated, producing a cloud, and then the air parcel becomes warmer than the surrounding air due to the condensation of water, because that condensation process releases energy. And then, so we call that air below that cloud conditionally unstable, because we have this air will only become unstable if it rises to a point where we have that condensation happening, and then it becomes warmer than the surrounding air, and then we end up having unstable air above it and producing those cumulonimbus clouds. So those are your three categories: stable, unstable, and conditionally unstable. So we're going to sign off and come back and talk about clouds and how clouds form in the next video.